Okay, sige, let's start. Sorry. And welcome to our third module lecture, synchronous meeting for CE18. And in this lecture, we will redefine the concept of stress in the language of continuum mechanics. So, in your previous courses, inaral nyo naman yung stress, no, from ES102. Okay? Okay kayo sa concept ng stress from ES102. In this case, we will just redefine it, expand it a little bit so that maging general, no? Maging general na kapag nagbasa kayo ng mga research papers on stress, then you can understand what they are saying. Okay? So ito talaga yung notation niya. Yeah. The objectives of this lesson is of course we redefine the concept of stress. We will define the stress vector or what we redefine the stress or the state of stress of a point in an object as a tensor. And of course, manipulate it. Since we have tensor transformation laws, we can use those transformation laws we discussed last time to transform the stress. This is what you did in AS102 probably as a Morse circle, using the Morse circle. And of course, one of the most important things or concepts that you need to know about stress is the principal stress, because that's where most of how we evaluate structures, it is a metric of how we evaluate the damage in a certain material. Ayan. Sino dito, nabasa niyo na ba yung module 3? The stress? Just click yes kung nabasa niyo na, no kapag hindi pa. So that I know. Yan. No. Okay, sige. Kasi, ayan. So I hope na ano no, before we go, I go into discussing all of this in a synchronous meeting, I hope that at least may nabasa kayo or something. So sa susunod na mga modules, sana you read, at least scan so that you know what I'm talking about. Para kasi ang concept of actually ang reading or reading a new material requires you to revisit it all that at some point. So alam niyo yung SQR3, diba yung parang scan, formulate your questions, read, review, and I don't know the other R. Pero basically ang learning something new is basically you scan the whole object and then formulate your question, and then you just read the material and then review the material. So I think this synchronous meeting would best fit if you read the modules first. But anyway, I'll try to make things more concise and for you to understand it better easily. Okay? Sige, let's proceed. We have this, you know this, we have this normal stress, okay? And the shear stress. Ayan. So pag sinabi nating normal stress, the force, ayan, the force F, ayan, the force is normal or perpendicular to the area. So in this case, in this side of the object, in this inclined area A theta, okay, the normal stress would be F over A theta, right? And of course, the shear stress, so yung shear, yun yung kumikiskis na stress, no? Yan. It is the V over A theta. So force over area lang. That's the basics of stress. Ayan. So to generalize the idea, we define the stress vector as the traction. Okay? It is simply the resultant. Ayan. So this the resultant of the normal and shear stress. So the resultant of this is the traction. Also, of course, we can also call each of this yung sigma, the normal stress, and the shear as stress vectors, no? Since ang components naman of a resultant vector is also a vector. So we can also say that these are a stress vector. But for an area, the stress vector is the traction T. Okay? So just to generalize the idea. In general, the traction is the total force F divided by the cross-sectional area. Okay? Now, let's look at the left side. So, at the left side, yan, left side, ang area dito is A, right? So, the traction here is F. So, since equilibrium naman yan, so the left side force will be equal to the right side force, F over A. For the right side, parehas pa rin yung force, but the cross-sectional area, yan, will be A over cosine theta. So if this is A, right, then this should be A over cosine theta. Everything clear so far? Yes, please click yes kung okay pa. Okay. Okay, sige. So, ang ginawa lang natin is just to redefine the stress as a traction. Ayan. Now, we define a stress tensor. So what is a stress tensor? If we look at some point, okay? If we look at some point in an object and try to make a stress block out of that point. So for example, let me draw. We draw some things. For example, this is your material. Okay? Now, this is acted on by some forces. So my force dyan, my force dyan, my force dyan. Now what you do is look at one point. So say this is the point that we want. Kita nyo naman? Kaya natin ng konti. So this is the point that we want. Look at that point. And if you magnify it further, it will look like this. Okay? It will look like this diagram. Okay, so it will be represented by a cube. This is what we call a stress block. And we can see that may mga stress siya. So stress na ganyan. May sigma na stress. What you can notice here is and how do you get this? How do you get this, class? Alam ko ginawa niyo na to sa ES 102 eh. So you get that by using equilibrium equations, tama? Using equilibrium equations to get or to determine the internal forces, and then those forces you convert it to uh, to stresses by dividing it by the area. Okay. So may mga problems na ganyan, no? Please revisit ES 102 or you can consult with me kung meron kayong mga problems na makita na uh, hindi nyo alam kung paano gawin itong stress block na ito. Okay? Now what you can notice here is pinalitan ko, okay? Pinalitan ko yung sigma, yung mga shear stresses. 'Di ba? Dapat tau ito, 'di ba? Yan. Ito mga shear stresses yan. These are shear stresses. Pinalitan ko yung sigma, pinalitan ko yung tau ng sigma for shear stresses. Okay? Why did I do this? I want to, again, as I've said earlier, I want to generalize things. We want to generalize things so that we can put it in an indicial notation. So the indicial notation then for the state of stress of a point, okay, is sigma ij. This is what we call the stress tensor. So ang notation is that I, okay, so sigma ij is the plane on which the stress component acts. Okay? And then j is the direction of the stress component. So for example, let's look at sigma 22. Okay? Sigma 22. So ibig sabihin, at plane 2, tama, the stress acts on plane 2. Okay? Where is plane 2? The plane 2 is perpendicular to the x2 axis. So this is the x2 axis, okay? Yan. That is the x2 axis. This one. And the plane perpendicular to the x2 axis is this plane. So as you can see, it acts on plane 2. And the direction of the stress component is directed along x2. So pareha sila ng pino-point out. Let's look at other stress. Ito naman, sigma 1, 3. So 1, ibig sabihin, it acts on plane 1. So what is the plane? What is plane 1? Plane 1 is perpendicular to axis x1. Okay? And the direction of the stress component is 3. So yan, 3. Ibig sabihin, it is parallel to x3. Naintindihan naman yung notation? That is the notation. Okay tayo ha? Now you might ask, Sir, meron bang sigma 22 dun sa kabilang direction? Yes, no? So how would it be named? Would it be named something like this? Ayun, acts on negative to axis. And points on negative 2. No. Mali ito, mali. So sigma 22 pa din, no? Sigma 22 pa din. Doon sa naming convention natin, hindi natin nilalagay yung mga signs. So doon sa values tayo maglalagay ng signs. So ito naming convention lang ito. Okay? Naintindihan so far? Yes? Yan. Please click yes kung okay kayo. Okay pa kayo? Okay, sige. Walang questions ha? Nasa convention pa naman tayo. Okay, sige. And we note that the stress tensor is symmetric. What does it mean? What does it mean if it's symmetric? It means that this one is equal to this one, okay? This one is equal to, try natin yung 4. Yung, this one is equal to this one, okay? What else? This one is equal to this one. Okay? So yung upper triangle is equal to the lower triangle of the matrix. Okay tayo sa symmetric? Why is this symmetric? Can we let's have why is the stress tensor symmetric? So kung maalala nyo doon sa discussion nyo sa ES 102, okay? Kung maalala nyo, we have this stress block, 2D stress block muna. So we can represent by easily, no? So if this is sigma, okay? Sige, yung connotation nyo muna dun sa ES 102. This one is sigma y. Sigma y. Tama ba yan? Yan. And this is the tau. Tau, what is this? Tau acting on x directed at y. Tau at y directed at x. So this is tau xy. This is tau yx. So here, if we write it in the C18 form, right? So meron yang sigma xx, sigma yy, sigma xy, sigma yx. Okay? So what does this say? Sorry, dapat tau pala. Let's put it in here. So ganyan lang ang tsura niya, no? Tau xy. And because the tensor is symmetric, or the matrix is symmetric, this is equal to this. So we say that tau xy is equal to tau yx. Why is that? We need to satisfy equilibrium. Okay? So bakit siya symmetric? Because of equilibrium. So as you can see here, in order for this stress block to be in equilibrium, the stress tensor should be symmetric. Okay? So kaya siya symmetric. Okay, let's go back to this. Okay. Ayan. So who is this? Si Cauchy, right? So si Cauchy, sabi niya, merely knowing the stress vectors on 3 mutually perpendicular planes passing through a point, we can find the stress vector on any other plane passing through that point through coordinate transformation equations. Ano ibig niya sabihin? Sige, isa-isahin natin. So, what do we want to have? What we want to have is the stress vector on any other plane. What do we have? what should we have? So what should we have is the stress vectors on three mutually perpendicular planes passing through a point. And what is that? Okay, what is this? What is this thing? This stress vectors on three mutually perpendicular planes passing through a point. This is the stress tensor, right? So that is the stress tensor. Kung babalik tayo doon sa definition niyan, yan oh. That's it, right? That's it. These are the stress on mutually perpendicular directions passing through a point, which is this stress block. Ayan. And what does he say? Ito. Balik tayo doon sa isang slide. What does he say? Ayan. So, by merely knowing the stress tensor, we can derive, sabi niya, we can derive at any direction, ano yung sigma and ano yung tau, kahit anong direction pa yan. And guess what? You were doing that for in ES 102 using the Mohr circle. Tama? Ginagawa niyo ba yon? Sino nakakaalala pa ng ES 102? Mohr circle. Please click yes para alam ko. I know. Okay. Sige, sino nakaalala? Please click para alam kung on the same page ba tayo o hindi. Sige na, guys. Alam niyo pa? So ayan. Sige. So I suggest you review those things dun sa mga hindi pa nakakaalala, right? So review the Mohr circle. Pero actually this method that I will teach you is more it makes much more sense to me, especially if the one limitation that I can think of in the Mohr circle, although you can extend it, although it's hard, is that mostly it's just applied to plane stresses, right? So plane stresses lang siya. So how will you extend it if meron ka ng 3D stress block? So that's what we're going to study in this module. Okay, let's move on. Yan, tapos na tayo dyan. Yan. So we have this Cauchy stress principle where it says that the traction or the stress vector at any other direction at some, the traction or the stress vector at some direction n, okay? Or wait lang. Let me just repeat. So, ulit. The stress vector, okay, at an area defined by the unit normal vector n, okay, is equal to the stress tensor multiplied by the unit normal vector n. Malinaw ito? So, sorry guys, medyo magulo lang dito sa bahay. Okay, so let's proceed. Let me just take note that this n, okay, this superscript n is not an exponent. Okay, so wag tayo malilito. It's just a convention. It just says that the traction is in the area defined by the unit normal vector n. Okay. Sige. So for example, let's have an example. Determine the stress vector on a plane which passes at point P with a unit normal vector n equals 1 over 7, 2 e hat 1 minus 3 e hat 2 n plus 6 e hat 3. If the stress tensor at point P is this. Okay, so hindi mo na kayo pinahirapan. Binigay na sa inyo yung stress tensor at P at binigay din sa inyo yung normal vector. Okay, so how do we do this? Well, let's just substitute it to the Cauchy stress principle. Ayan. So the Cauchy stress principle states that this one. Now, again, this is a indicial notation equation. So it's very important that you remember what the dummy indices are and the free indices are. Okay? So what are the dummy indices? The dummy index is J, right? So how do I expand this? I expand this by making it a sum. Sorry. Mali pala ito. This is a correction. Okay, sorry. This should be 3. Okay, same as this. So take note lang dun sa notes nyo, pakipalitan na lang, this is 3. Ayan. So, we expand it as a sum. And then, the free index is I. Tama? So, we expand it by expanding I as 3 equations. So, this one is equation 1, equation 2, equation 3. Okay, so now we're ready to substitute, right? Substituting, we get this. So noting, yan, 21, negative 63, 42. Just substitute everything. And we get the components of the stress vector. Okay? So I hope you do this again on your own and check if you have the same answer. Okay, madali lang naman, no? Okay. Next. So ito na. This is how to transform the stress tensor. So remember again, I will repeat that the stress tensor represents the state of stress of a point. Okay? Now, in some cases, we want to transform the stress tensor or define, again, the definition of transformation. When we say transformation, is defining a tensor in another coordinate system. In this case, we want to get the components of the tensor. Okay, we want to get the components of a tensor in the primed axis, x1 prime, x2 prime, and x3 prime, defined by these arrows in the red color. Okay? So how do we do that? Ayan. So balik tayo dun sa Module 2. Sa Module 2, tinuruan na kayo ng transformation law. And we note that a stress tensor is a second order tensor. So ibig sabihin, kapag second order, this is the transformation law. Naalala pa naman, no, kung paano kunin yung Q, right? So, ganun lang siya. Applying that, so let's have an example. Find the primed components of a tensor if the primed axes are given by rotating the unprimed axis by 45 degrees counterclockwise about the axis x3. Okay, so what happened is that yung x3 prime pa rin, hindi siya nagbago. Tama, parehas pa rin sila. Yung x1 na-rotate ng 45 degrees, pati yung x2, 45 degrees. So they have the same rotation. Same with that. Same with this. Okay, same lang yan. Okay? Move on. Ayan. So, this is the transformation matrix. Okay? Naalala pa kung paano? So, this one, row 1, again, row 1 represents the components of, mali pala, sorry, the x1 prime. Row 1 represents E hat 1 prime. At 1 prime. Row 2 represents E hat 2 prime. Okay. Lastly, 3 is E hat 3 prime. Okay. So paano yun nangyari? Since 45 degrees, you just get this one. So we know that since this is 45 degrees, cosine 45 is 1 over square root of 2. And sine 45, this one is sine 45, is 1 over square root of 2. Here, the x1 component of x2 prime is negative. Okay? Negative 1 over square root of 2. And the x2 component of x2 prime, of E hat 2 prime, sorry, is 1 over square root of 2. And this one, since parehas pa rin yung direction, then it's just 0, 0, 1. Okay, malinaw tayo dito. Nakasunod naman kayo? Yes? Nakasunod kayo? Yung iba? Sige. Malinaw ha? I'll proceed. Now, what we just do is just to expand, okay? Expand this initial notation, right? In order to get this. Okay? So, ano yung, again, we take note of what the free indices are and what the dummy indices are. The free indices here are M and N, right? So I shall expand this into terms. So how many terms does does each equation, wait lang. So free indices muna. So ano yung free indices? It's I and J, right? So how many equations should I have? Okay, paki-chat na lang para meron tayong 9. Tama, no? 9. Thank you. So ayan, 9 equations. Why? Kasi this has 3 times 3. Okay, so 9. How many terms should I have per equation? 9 rin. Yes, correct. So, tama, no? So, kasi dalawa rin yung dummy index ko. And we are in a 3x3, 3D analysis. Okay. Just an example siguro bago tayo mag-proceed with this. Let's go back. Let's go back. Dali lang ah. So, balik lang tayo. Qij, okay, is equal to this. 1 over square root of 2, 1 over square root of 2, 0. Negative 1 over square root of 2, 1 over square root of 2, 0. And 0, 0, 1. Aha. And we have sigma ij equal to 1, 3, 2, 3, 1, 0, 2, 0, negative 2. So just an example, we have this equation. Sigma ij prime is equal to qim qjn sigma mn. Suppose that we want to get, okay? Suppose that we want to get the component of sigma prime. Anong component? Siguro 2, 3 na lang. 2, 3. Okay? Something like that. So, we have Q, I, 2, QJ, 3, QJ3. Mali, sorry. Q2M, Q3N, sigma MN. Now, expanding this further, we have Q21, Q3N, sigma 1N plus Q22, Q3N, sigma 2N plus sigma sorry, not sigma, Q23, Q3N, sigma 3N. Okay? Now, expanding this further, okay, sana kasha. So, Q21, Q31, sigma 1, 1 plus Q21, Q32, sigma 1, 2 plus Q 2, 1, Q 3, 3 sigma 1, 3 plus, ako hindi kasya, no? Okay lang yan. Q 2, 2 Q 3, 1 sigma 2 1 plus Q 2, 2 Q 3, 2 sigma 2, 2 plus Q 2, 3 Q 3, 3 sigma 3, 3. Ay, mali. Nagkamali ako. Q 2, 2 Q 3, 3 sigma 2, 3. Di kasya. So dito ko na lang isulat yung continuation. Plus Q 2, 1 Q 3, 3 sigma saan na ako? Q 2, 3 3, 1 sigma 3, 1 plus Q 2, 3 Q 3, 2 sigma 3, 2 and plus Q 2, 3 okay, Q 3, 3 sigma 3, 3. Ayan. So that's how you get ano yung sigma 2, 3. That's how you get if you evaluate all of this, ayan, if you evaluate all of that, you should get negative square root of 2. Okay? So, ayan siya. Ayan, so you should do it ayan, for all of these components. So 9 components. That's why you have 9 equations. Okay ba? And this is the equivalent of the Mohr circle. So if ayaw nyo mag-Mohr circle, ayan, you can do this. So for plane stress naman, it's much easier because how many components do you, it's just 2D. So how many equations do you have? You only have 4 equations, right? Actually, you you don't need to do this for all the elements of this matrix. Bakit? Bakit kaya? Anong pwede nyong gawin para mas umiksi yung trabaho? Yes, correct. Equilibrium meaning dapat symmetric. Ayan. So as you can see, the result of this operation is a symmetric matrix. Ayan. Symmetric pa rin ito. Symmetric. This equal to this. Ito equal dito. This one is equal to this. So pwede nyong gawin is just compute for how many? 1, 2, 3, 4, 5, 6. Okay? Okay tayo? Yes? Yan. Okay, sige. Let's proceed with a more difficult problem. So this one, what we want to get is the principal stresses and the principal directions. Okay, ano ulit yung significance ng principal stress? Okay, can anyone chat? Para lang alam ko kung alam nyo. What is the significance of principal stress? Ayan. Max stress or no shear stress. Okay. Theories of failure. Ayan. So, you might remember theories of failure, right? For Tresca's hexagon or von ayun. Theories of failure, no? We use the principal stress. Why? Kasi, para saan ba yung theories of failure? The theories of failure kasi is a theory on how materials fail. And why do we need that? Because ang metric lang natin ng failure is by using the uniaxial stress test, right? Like tension test. Ang ginagawa dun sa tension test is you have a material. So you have a material, for example, steel bar. So ang ginagawa dun sa tension test is that you determine the stress strain curve, right? So ang tsura, siguro ganyan. And here, you have the sigma y or the yield strength. And here you have the ultimate strength. Okay? Now, the problem with this is that paano na ngayon kung 2D na yung application or 3D na yung application ng stress mo, right? Hindi na uniaxial. So hindi mo pwedeng sabihin na kapag at this direction nag-fail na by yield, then doon na siya mag-fail. There are times that kahit in both direction it doesn't fail by yield, the material already failed. So those are described in the theories of failure. And in the theories of failure, we normally use the principal stress as a metric. Okay? So ano ba yung principal stress? The principal stress is the stress on a stress block So sorry guys. Saan na ako? In the theories of failure, we have a metric of principal stress. So ano ba yung principal stress? Yung principal stress is the stresses at a stress block in which there are no shear stresses, okay? Such as this one. So what we want to find is the direction and the principal stress direction or the direction where you get the principal stress and of course the values of the principal stress. Now, you might recognize this one. So this sort of equation, okay? as an eigenvalue problem. Okay? So yung eigenvalue problem usually has something like this. A x equals some eigenvalue lambda x. Something like that. Okay, so ano yung sinasabi nito? There is a very good YouTube series you might want to check out, yung 3 Blue 1 Brown, where it discusses ano yung mga physical significance or physical visualization of these mathematical concepts like the eigenvalue. So yung eigenvalue, eigenvector, parang kumbaga, ito kasi this is a scalar, di ba? Tama? Eigenvalue. Kumbaga, you are finding an orientation wherein you just the object just expands and hindi siya nag-skew. So ano yung orientation na yon? This is the principal stress orientation. Tama? In this case, the material only expands. Walang shear stresses, so it doesn't skew. Okay? Hindi siya nagro-rotate. Okay? Yan. Let's move on. So now, we solve the eigenvalue problem. Okay? So ito medyo mathematical yung formulation. So I hope makasunod kayo. So we start with this equation, this eigenvalue problem equation. Sigma ij nj equals lambda, which is the eigenvalue. Okay? This one is a scalar. Okay? And delta ij, this one is the Kronecker delta. Okay, so it has as a recall, it has only a value of 1 if I and j are the same and 0 if they are not the same. And of course, nj. Okay, now moving everything to the left-hand side of the equation, we get this one. And I just put this here, 0, 0i, because I want to emphasize that I is a free index. Diba? From this equation, what can you say? From this equation, I is a free index because it just appears once in a term, right? It appears once in a term. So as you can also see here, it appears once in a term. So dapat, para maging valid yung initial notation equation ko, dapat meron akong subscript na I dito. And I'm just saying that at any equation I, the right-hand side is 0. That's what I'm saying. Okay? Now, factoring out nj. Yan. Factoring out nj. Now, may comment ako dito. May side comment ako. Sabi ko, nj equals 1. What does that mean? I'm saying that the vector nj, or the first order tensor nj, has a magnitude of 1. Why? Because it is a unit normal vector. It is a unit vector, right? So by taking, for example, by taking the square of each element of this vector and adding them, okay, I get 1, right? Now, since this also, in order for this to be valid, okay, the determinant of the one in the parentheses should be 0. Okay. So that's how you solve it. Now, from the first module, I told you the definition of the determinant for indicial notation. So we do that. Okay, we do that. Ayan. Nakakasunod naman so far? Please click yes kung nakakasunod, no kapag nalilito kayo. So, and then you just chat me saan kayo nalilito. Sige. Okay, sige. Ayan. So, thank you for responding. Ayan. Now, we solve this one. The determinant of this term is 0. So, we recall this from the first module, right? Ayan. And we apply this definition to our equation. So 1 over 6 epsilon ijk epsilon rst. Instead of AIR, I replace A with this one. So sigma IR minus lambda delta IR. Okay? JS, lahat ito JS. KT, all of this is KT. And this is 0. So, how many free indices do we have here? Can anyone chat? How many free indices do we have? Merong 1, merong 0. Ano pa? Any other answer? Okay, so we have 0, no? We have 0 free indices. Why? If we expand here, everything is repeating, right? IJK, it repeats. This is I, may I dito. Of course, J, it also repeats here. RST also repeats. RST. Okay, so everything repeats. Ibig sabihin, all of them are dummy indices. Okay. Now, since all of these are dummy indices, ang result nito is just one scalar value. And that makes sense because we're talking about determinant. And a determinant for a matrix is just one scalar value. Okay, just remember that. And what we do here is expand this equation. Okay, expand this equation. And if you expand this, you should get a cubic equation. Okay, just take note. You should get a cubic equation in terms of lambda. Why cubic? Kasi we are talking about 3D, so a cubic equation can solve 3 values for lambda. And what does lambda represent? It represents the principal stresses. So in a 3D stress block, okay, 3D stress block, we have 3 principal stresses. Okay? Ayan. Now for principal directions, so nakuha na natin kung yung mga values ng lambda. So for each lambda, we have 3, right? For each lambda, you solve this equation and also solve this equation to get NJ. So what does NJ represent? It is the principal stress direction for this principal stress lambda. Okay? So ayan. Siguro this will be better if we put it in an example. Yeah, so we find the principal stresses and the principal stress directions in this given this state of stress for a point. Okay. So again, we expand this equation, right? This is just the determinant equation. And by expanding this, okay, we should get this cubic equation. Okay, so at home, since medyo mahaba-haba ito, okay, at home, I want you to verify this equation. Just as a practice na rin for expanding initial notation. Okay? And if you solve this cubic equation, you should get 3 values of lambda, which is 25, 50, and 75. And this is these are the principal stresses. Okay? Ayan. Now, let's solve for the principal stress direction. So we now have the principal stresses lambda, right? Which is 25, 50, and 75. Now we want to get the directions of each of those principal stress. So we expand this equation, okay? So again, we note that the free and dummy indices in the initial notation. So we note that I is a free index, okay? Which means that we have 3 equations. These are the 3 equations, okay? These are the 3 equations. And of course, we expand J as a dummy index. So we expand it in terms of, in 3 terms, 3 summation terms. Ayan. So we're ready to solve. And of course, dapat this one, nj equals 1, which means that the direction that we should get should be a normal vector. Okay, let's solve. Yeah, so substituting, right? Substituting sigma ij. Yan, so ito yung given sa atin, di ba? 57. Okay. Bakit dito 0 lang? Bakit wala yung minus lambda sigma ij at lambda delta ij? Because delta ij is 0 if I and j are not equal. In this case, I and j here, I is equal to 1 here and j is equal to 2. Kasi row 1 and column 2. So walang value dyan yung lambda. Walang value dyan yung delta. Okay. So just substituting everything. Okay naman kayo? Yan, 0, 50 minus lambda. Okay naman? Please click yes kung okay pa. Kung naintindihan itong yung nangyari dito sa slide na ito. Okay, sige. Then, ayan. So we do this equations, we do this solving of n for every lambda that we have. So we have 3 lambda, so we repeat this 3 times. So for lambda equals 25, ayan, I just substitute lambda equals 25 to the set of equations that I have in the previous slide, and I get these 3 equations. Okay? Ayan. So for example, sa anong galing yung 32? 32 is from 57 minus 25. So that is 32. Okay? Yan. So sinubstitute ko lang siya. Tapos, ayan. From equation 2 from the previous slide, n12 is 0. So again, yung superscript, no? Yung superscript, it's not an exponent. I'm just saying that this is the direction of the first principal stress. So the first principal stress is 25. Okay? So balik tayo dun sa previous slide. Dito ko na lang siguro i-solve. So from here, sabi yung n21 is equal to 0. By just dividing this by 25 both sides, we can get n12. What else? From 1 and 3, n13 is negative 4/3 n11. Okay. So if we go back, here, these two equations actually say the same thing. Okay, so if you simplify both of these equations, they say the same thing. That is n13, yeah, is equal to -4/3 n11. Okay, and that's quite normal if you're solving eigenvalue problems. Okay, let's move on. And that's why we use this equation indicating that the the vector that we should get should be normal. So just substituting everything here, n11, n11, yung n12 is equal to 0, so that is 0. And then substituting here equals 1. And then solving for n11 here, we get this value, right? And then substituting to get n13, we get this equation. So all in all, we get this direction. So this is the direction of the principal stress equal to 25. Okay. Now we do the same thing. We do the same thing for lambda equals 50 and lambda equals 75. So just a piece of advice, okay? Wait, just a piece of advice. Sige. Sir, sa lambda equals 50, hindi po ba magkakaroon ng 0 equals 0 sa second equation? Sige, let's try to, sige na nga, pakita ko kung paano. Let's try to solve this. So what we have is 57 minus lambda n1 plus 24 n3 equals 0. 50 minus lambda n2 equals 0. And 24 n1 plus 43 minus lambda n3 equals 0. So yung ang tanong is dinig ako, dinig. So ang tanong is magkakaroon ba ng 0 equals 0 sa second equation? So again, as I'm saying earlier, it's quite normal for an eigenvalue problem. That's why we need to have this one, nj equals 1. So substituting the lambda equals 50, what we get is 57 minus 50 is 7, and 1 plus 24 and 3 equals 0. And then here, 50 minus 50, 0. So 0 equals 0. Doesn't mean anything. So we are left with just two equations. So yung equation na yun is 24 and 1 plus 43 minus 50, negative 7. Tama? And again, as you can see here, meron na namang bizarre thing na nangyari. Right? Sabi dito, n1 equals negative. So here, 24 over 7 and 3. Sabi naman dito, N1 okay, is 7 over 24 N3. So ano yung tama dito? Okay? So ano yung tama dyan? How will this be true? Okay? How will that be true? Can anyone answer sa chat, or even you can turn on your mic? So when will this be true? May conflicting statements tayo. Pag 0 po yung both N1 and N3. Very good, no? So this can only be true if N1 and N3 is equal to 0. So if that's the case, then there's no conflict. Tama? Now, we have to satisfy this one. Okay? We still have to satisfy that one. So I know that N1, N1 plus N2, N2 plus N3, N3, let me just delete this, equals 1. Right? But this one is 0. So I am left with N2 should be equal to 1. Okay? So ganito mag-solve ng ng principal directions. So medyo nakakalito. Okay? And thus we get the result na pinakita ko kanina. And thus we get that result. Okay, sige. Ayan, there's actually a shortcut. Ayan, may shortcut para hindi nyo na ulitin for N3. Ano yung shortcut para hindi nyo na ulitin sa N3? Can anyone answer? Oh, hint. Ang hint ay we are dealing with mutually perpendicular directions. So, ano yung relationship ng N1, N2, and N3? They should be perpendicular. And thus, if you have N1 and N2, what should you do to get N3? Guys, what should you do? Cross product. Okay. So, N1 cross N2 is equal to N3. Very good. Okay ba tayo? Sige. That ends our lesson. So first, we have defined the stress vector, or what we call the traction. And then we discussed the Cauchy stress principle. Okay. Then we use this. We use the laws of transformation to transform stresses. Right. Then by using transformation, we have determined the principal stress. Okay. And all of this using continuum mechanics. So ang maganda sigurong exercise is to compare all the results in this lesson with what you have learned so far in ES 102. Right? Like the Mohr circle, and evaluate ano nga ba sigurong mas madali. Okay? Siguro yung mas madali. Sige. So do you have any questions? Do you have any questions so far? May questions kayo, guys? Wait lang ah. So ayan. Um, sige. Please, please answer this para alam ko kung uh, ano yung effect ng synchronous classes natin so far. Okay, so 1 is the lowest, 5 is the highest. Okay. Yung iba guys, sige. Ayan. Thank you. So siguro, as promised kanina, uh, beyond what, Kasi ang synchronous meeting talaga is designed for us to have a forum sana. So hindi ako nagsasalita lang. So I guess it's a good time siguro to discuss your formative assessment and how you plan to do it. Right? So pakita natin. Nakita niyo na ba yung yung formative assessment niyo? Okay? Ayan. So let me just show your formative assessment. Ayan, for the remaining time siguro, we can discuss. You can also ask me questions on how to do this. Basically, ito yung mga guide questions. I suppose that you can do this one, right? Even from the first meeting that we have. Uh, ayan. Actually, kailangan pa pala nung next meeting, no? So the strain tensor. We need to first discuss this strain tensor before we can proceed with the other things. But I hope that ito, mag-guide na kayo on what to do. So may kwento siya, no? Ayan. Pakibasa na lang. You can also ask me now if may malabo ba dito. So 2D lang tayo. Did you understand the problem? May mga terms ba kayo na hindi naiintindihan dito? Okay naman? So strain gauge, kung sa mga nakabasa na, strain gauge looks like this. Okay? So what does a strain gauge do? It measures the strain in one direction. Okay? So kung ganito yung orientation ng strain gauge nyo, it uh, it measures the strain in these directions. Okay? So hindi niya ma-measure yung sa ibang directions, no? That's why in the problem, the one who emailed you, okay, which is Tony Stark, attached strain gauges in different directions. Okay? So ayan. I hope that siguro by the next meeting, we can already start with with the formative assessment. At least you have a guide on a problem, right? You have a guide on a problem that you want to think about while we're discussing things. Okay, so yan yung mga usual problems ng continuum mechanics. And that's for testing. Okay? Ayan. So ito, simulan niyo na siguro ito. Compute the von Mises stresses. Even just expanding this, okay? Just expanding this. Ayan. Also noted dun sa course guides natin na you can do this in any creative way you like, no? I would be happy if I see that you work creatively. Again, I want to emphasize that engineering is not only for solving, right? Solving mechanical problems, but rather showcase your engineering is more of an art and not just applied science. And mostly in engineering, you need to develop also your communication skills because you're working with teams and collaborate with other people. So I hope that you do that. And I would be very happy if you do that. Okay? Sige, may questions pa? Wala naman? Okay naman daw? Sige. Okay? Siguro would you want to to have like groups ganon for this formative assessment, pero not of course for solving, but rather just to share your ideas on how to solve or what you plan to do, ganyan. Good, we can have those sessions din naman. Okay? Sige. If you have no questions, then thank you for coming in this synchronous meeting. And yeah, good luck in this sem. And stay healthy. Thank you.
Thank you, sir.